Through this proof of number 6, this biconditional statement involving sets. So I can see that you're kind of talking to me here, and I'm having trouble to follow after this first sentence here. So let me just talk through what I've got, and then hopefully I can give you some direction from here. So if we want to prove an if and only if statement, we have two directions that we need to prove. So I can see that you're proving the first direction here, the forward direction. If A intersect B is equal to A, then A is a subset of the set B. So that's the first part of the proof. Now it looks like maybe your next step is to prove the other implication. So just to be clear here, you're proving an if-then statement, so you want to use if A is a subset of B, then A intersect B is equal to A. So those are our two pieces of the proof, so that looks good. I'm glad that both of those conditional statements are here. So if we want to show this conditional statement here, so let's focus in on part 1. We can do this actually with a direct proof. We don't need to use the converse or the contrapositive here. And so basically what you can do to prove this statement, let me give you an outline here. You can start by assuming that that X is an element of A intersect B, and because we want to prove that A is a subset of B. Okay, so I'm just trying to follow this sentence here. So let's assume, or we can just say assume that X is an element of the set A. Yeah, you could just say equivalently, or X is an element of A. So I think before you go into putting X in A, you want to have a clear starting assumption that you're going to assume the hypothesis is true. So I would insert a sentence before this one about X being an A, to say assume A is equal to A intersect B. Because what you're doing here is you're using that assumption actually. Because what we're trying to show eventually is that if X is in A, then X is in B. And so once you assume that A is equal to A intersect B, you say, okay, take an element in A, show it has to be in B. Well, if X is in A, then I know that because A is equal to A intersect B, if that's true, then if X is in A, X must be in A intersect B. If X is in A intersect B, then X is in A and X is in B. Okay? And then you've got your final conclusion here that X is in B. So I think you just need a little bit more detail here, and you want your final conclusion here to be that X is in B, so then that tells me that A is a subset of B. Okay, let's just add a couple more sentences here, a little bit more detail to be clear on what your conclusion and assumptions are, and then we will look at this other part. And I think maybe you're just trying to make a note to me here, so I'm going to kind of ignore this sentence here. So now we want to prove if A is a subset of B, then A intersect B is equal to A. So you're saying, okay, so I can see, okay, we're trying to prove set equality here. So there's two parts of this that we have to complete. We have to show that A intersect B is a subset of A, and A is a subset of A intersect B. So you're saying, maybe you're trying to show this element, this subset relationship first. Be clear here that your starting assumption here, again, add that sentence, assume your starting assumption is that A is a subset of B. Okay? I did something funky here. So we want to include that assumption because we're going to use it. So assume A is a subset of B. Okay, then you're saying take an element in A. I know, yep, from my assumption, A is a subset of B. Good. It means that Y is also in B. Good. So, yeah, Y is an element of both sets A and B. Well, and yeah, you can just say, and thus, Y is in the intersection of A and B. Okay? And, yep, we showed here that A is a subset of that A here, just A is a subset of A intersect B, okay? Since Y is the only element of the set A, oh, but we don't know that actually. We don't know this. We don't know that. Let's see, so we need one more piece here. We need to also prove that A intersect B is a subset of A. So the way you're gonna do that, is take an element here and show it also has to live in here. So you're gonna, after you end up here, after saying, okay, we showed that A is a subset of A intersect B, you're gonna go into showing that A intersect B is a subset of A. So I think maybe that's what you need right here before you go into here. And so just remove that thing about Y being the only element, because we don't know. We do want to eventually conclude that the sets are equal, but we need to prove this first. So to prove this, let me just try to write it out so that you can kind of see. So let X be an element. So it's like another little portion. This part of the conditional has two pieces to it. So really this proof you could think of having like 3 different pieces in it. So to show subsets, we just take an element in the first set, then X is in A. Therefore, so that's all the little piece we need to include to show that this subset relationship also holds. Okay? So just kind of insert something to that order there. That if, yeah, and then just watch your wording here. We're proving if A is a subset of B, then, okay. So I hope that helps. It kind of might be looking overwhelming, but I'm happy to, look at a draft and get back to you if you want to revamp it based on these comments, okay?